It might be mistaken as only a mastering tool, but it isn't. It is as effective on channels, groups, and the master bus. I'm using a gentle knee and low offset value for the saturation drive response. Using it in a single band mode with very little shift values, the saturation effect is kept to a minimum. The clipper at the output not only controls the output gain, but can be used as another stage of processing. The combination of these simple settings affords a beautifully controlled and expansive texture that does not hinder any frequencies at the channel stages. Most saturators that are combined with clippers give great results, but with some compromises. Kraftur navigates all the regular pitfalls like aliasing and oversampling into modulation distortion like a Jedi. The level of control over the integrity of the audio that gets punished with saturation is sublime. The color, well, listen for yourself. It opens up the whole mix and takes us back to cuddly audio days. Okay, enough tubes. Let's now move on to tape. Ah yes, tape. Most engineers my age will have had to work as a tape operator. My bad, studio coffee maker. When first starting out interning at commercial studios. It was a responsible but arduous job. However, it did teach us a great deal about how tape machines work, how to use tape, and more importantly, how best to coax a great recording out of such a compromised and non-linear device and medium. Don't be fooled into thinking that we aimed for color when using tape machines. On the contrary, we did everything we could to achieve a clean and transparent recording. I have no desire to visit that era in my life again, and I'm so glad that software developers have furnished us with software tape emulators. All whinging aside, tape, and in particular tape saturation, does impart a certain characteristic to audio that we seem to like. But it's not just tape saturation that colors. The very nature of the medium also has characteristics that can be good or bad. A gentle rolling off at the top end or the head bump at the low end can actually be used to shape and hone specific frequencies. For example, reverbs and delays sound very different when printed and played back to and from tape. The very smearing properties and top-end roll-off can give a thicker and denser texture to reverbs that digital cannot achieve without some work. The stretching and contraction of tape and the controlled tape head's behavior can also give a pleasing response to a sound. It's not an accident we have tape delays, and on inception, they gave rise to new genres. They sound markedly different to their digital counterparts. Even head bump can be used to achieve a certain low-end color. And it doesn't end there. The tape machine itself has some hidden wonders that can add depth and width to a sound, and that's apart from loop and playback control to create specific effects. It's interesting that the limitations and flaws of tape machines and the characteristics of the magnetic tape medium have lent themselves to some innovative sound design and mix processes. In example 4, I'm going to use IK Multimedia's TIAC A6100 Mark II tape machine to process the electric bass line from the earlier Puppet track. First the dry version. And now with the TIAC. The question as to whether tape emulation plugins sound and behave like their hardware counterparts is not a discussion I want to enter. I view tape plugins as effects and dynamics and use them accordingly to color and dynamically shape certain sounds. The settings I've dialed in are specifically for a low-end type of sound like an electric bass. Low frequencies on tape are a processing juggling act, and it can be easy to oversaturate and smear frequencies. So you need to plan each setting in preparation for the next setting. I always start with the bias setting. Bias is used to reduce overall distortion levels. A low bias setting will result in more distortion, and a higher bias setting will result in less distortion. But that's not the end of it. Intentionally overbiasing is a common technique used to produce a gently saturated sound, resulting in a rounder and warmer response. Underbiasing can also be used to smooth out high frequencies and add distortion to low frequencies. The effect is very context driven, so play around until you achieve the color you're after. I haven't gone crazy with the bias setting, instead experimenting with different values whilst listening to the bassline, and I settled on a halfway compromise. I've switched on repro, which passes the signal through the entire analog recording system. Input to record amplifier, to record head, to tape, to playback head, to playback preamplifier, to output stage. You can disable this if you want a simple input to output signal without the tape getting involved. Transport mimics the behavior of the mechanical transport, and the resultant small irregularities add to some interesting textures to the signal. Opting for stereo allows the slight differences between the left and right channels to shine through, which equate to a wider stereo field. I've set the playhead to cut a lot of low frequencies out, as things can get a tad overblown when saturating low frequencies. Adjust this to taste. Finally, and this is as important as the settings used, I'm using the 499 tape. This allows for less compression and distortion when driven and pronounces higher frequencies, which is perfect for sounds of this nature. The result, though subtle, is a deeper, wider, yet unnervingly clean bass texture. Gorgeous. In the next example, I'm going to run a short snippet I created through IK Multimedia's TIAC A3340S 4-track tape recorder, and also the Tape Machine 24, an emulation of the MCI JH24, using two different tapes so you can gauge how different they sound. First, the dry version. Now with the TIAC. And finally with the MCI. With the TIAC, I'm using the 911 tape, which is an emulation of the BASF SM911 tape, which claims to offer warmth and precision. To be honest, I prefer to let my ears make these textural decisions. Select the tape and listen to how it sounds. Done. I'm applying hefty bias to keep things a little less muddy and coupling this with a high-frequency EQ boost. This is on the record side of things. On playback, I've selected to moderately cut low frequencies. Transport modeling and true stereo are also engaged. With the MCI, I've duplicated the record and playback settings to offer you a ballpark A-B comparison, albeit with different machines. I've selected the GP9 tape. This is modeled on the Quantagy GP9 formula and sounds clean and punchy with less distortion and compression, a perfect compromise between analog and digital. They both sound excellent, but with subtle sonic differences in both color and control. I'll let you decide which you think sounds better. In the final example, I want to demonstrate how to use harmonic distortion to enrich staid synthetic sounds, and in this instance, a sample-based two-dimensional piano.